sixth part of the second chapter, circles. In our previous video, we saw opposite angles of a cyclic quadrilateral are supplementary. The other way of saying is, if the opposite angles of a quadrilateral are supplementary, we can draw a circle passing through all four of its vertices. Is it clear? That is, we can call a rectangle to be a cyclic quadrilateral. Why do you call a rectangle to be a cyclic quadrilateral? Because the sum of opposite angles in a rectangle is equal to 180 degree. So we can say a rectangle to be a cyclic quadrilateral. In a similar way, we can say an isosceles trapezium to be also a cyclic quadrilateral. See how you can prove it. I have drawn PQRS, an isosceles trapezium with all four vertices on the circle. Okay, now you know in an isosceles trapezium, these two sides are equal. That is, PS is equal to QR. Also, you know in an isosceles trapezium, base angles are equal. That is, angle P is equal to angle Q. Let me consider angle P to be equal to X. Let angle P be equal to X. Then what can you say about angle Q? Angle Q would be also equal to X, because we know in an isosceles trapezium, base angles are equal. Now also you know in a trapezium, one pair of opposite sides are parallel, isn't it? So what is this angle? We can say angle S is equal to 180 minus X. It is because when two parallel lines are cut by a transversal, co-interior angles are supplementary. Since angle P is X, we can write angle S to be equal to 180 minus X. Okay, now let us add the sum of opposite angles of this quadrilateral PQRS. So if you add angle Q plus angle S, what do you get? You get angle Q is X plus 180 minus X. X and X cancels. So you get sum of opposite angles to be equal to 180 degree. So what can you say about this PQRS? Isosceles trapezium PQRS is a cyclic quadrilateral since sum of opposite angles are supplementary. Let us discuss the problems in the exercise. Come to the first question. Calculate the angles of the quadrilateral and angle between the diagonals. You are given a circle and a quadrilateral with all four vertices on the circle. I have named the quadrilateral as ABCD for you to get an idea about angles. Okay, we have to find all angles of the given quadrilateral. For that, you need each angle. First of all, consider angle ACD. ACD is given to be 30 degree. Now, arc AD makes an angle ACD in its alternate segment. We know all angles made by an arc on its alternate arc are equal. So, we can say angle ABD to be also equal to 30 degree. It is because ABD and ACD are the angles made by arc AD on its alternate arc. They will be both equal in measure. Use the same idea everywhere. Okay, now consider arc CD. Arc CD makes an angle CBD in its alternate arc. Also it makes an angle CAD in its alternate arc. So what can you say about both these angles? They both are equal. Okay, that is angle CBD and angle CAD. Angle CAD are both equal to 45 degree. So we can write 45 degree over here. Is it clear? Now consider BC. Arc BC makes an angle BAC, also BDC in its alternate arc. So both the angles are equal in measure. So we can write angle BDC. It is given to be equal to 50 degree. So we can say angle BAC to be also equal to 50 degree. Let me mark the angle. So I got this angle to be equal to 50 degree. Is it clear? Now let us write all the angles. First of all, we can write angle A to be equal to 45 plus 50, which is equal to 95. Now we can write angle C, because we know ABCD is a cyclic quadrilateral. Opposite angles are supplementary. So we can write angle C is equal to 180 minus 95. This is equal to 85 degree. Angle C would be equal to 85 degree. Okay. Now we can write this angle. We know the full angle at C is equal to 85. Now subtract 85 minus 30. You get 55. So we can say this angle to be equal to 55 degree. Is it clear? Now if you look at arc AB, AB makes an angle ADB and also ACB in its alternate segment. So both these angles are equal. Since this is 55, I can mark this angle also to be equal to 55 degree, from which you can write angle D to be equal to 55 plus 50, which is equal to 105 degree. Now you can write angle B, because we know angle B plus angle D is equal to 180 degree. So angle B will be equal to 180 minus 105, which is equal to 75 degree. Now we need the angle between diagonals. It is very easy to write. 50 plus 30 gives you 80 degree. Therefore, the third angle of the triangle would be equal to 100 degree. You know, sum of all angles in a triangle is 180 degree. Now, since this is 100, vertically opposite angle here is also equal to 100 degree. And what about this angle? This is equal to 80 degree, because in a straight line, you know, the two angles form a linear pair. Since this is 80, opposite to it, you get 80 degree. We have found out all angles of the quadrilateral and angle between the diagonals. Is it okay, children? Come to the next question. A very important proof. Prove that any exterior angle of a cyclic quadrilateral is equal to the interior angle at the opposite vertex. A very simple proof which we use in many problems. So understand clearly. We are going to prove exterior angle at any vertex. To say about the exterior angle, I have extended the side AB of cyclic quadrilateral ABCD. So you got this angle, angle CBE is our exterior angle. We have to prove exterior angle at this vertex to be equal to the interior angle at the opposite vertex. That is, we are going to prove these two angles are equal. To prove it, we will use a very simple idea. Okay, let me name this angle as X, and let me name this angle as Y, and let this angle be equal to Z. Now you know ABCD is a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. So I can write X plus Y to be equal to 180 degree. Okay, let us name this as the first equation. Now we know angle Y plus angle Z to be equal to 180 degree because these two angles form a linear pair. Let us write that as the second equation. So we can write Y plus Z is equal to 180 degree. This is our second equation. Now you know these two values are one and the same. X plus Y is 180 degree. Y plus Z is also equal to 180 degree. So by comparing first and second equation, we can say X plus Y is equal to Y plus Z. Now you can see Y to be the common term in both the sides. So what you can do? You can just cancel Y with this Y. So what remains is X is equal to Z. X is equal to Z, where X is the interior angle and Z is the exterior angle at the opposite vertex, and hence the proof. The remaining problems we will be discussing in our next video. Thank you, children.